Bridging Mathematics, Trigonometry, Applications of Right Triangles. I am Engineer Brian J. Guzman, and I will be your lecturer for this particular topic. So in this video, our only goal is to now apply the principles developed in the solutions of right triangles to solve worded problems involving right triangles. Okay, so we're done with the solutions of right triangles, wherein we use the 6 trigonometric functions and the Pythagorean theorem to completely solve the missing properties or quantities in a right triangle. Okay, but these problems or those problems were just merely a given angle, a given side, okay, for a triangle was given and solved for the other unknown parts. But this time, in the worded problems, we're now going to create our triangle first, draw the corresponding figure, and then solve for the required part, whether it be an angle or a length. Okay, so we're not really necessarily solving for every part of the triangle per se. Now, one of the interesting uses of trigonometry is its applications to problems involving heights and distances which are difficult or sometimes impossible to measure directly. Solving right triangles is commonly used in cases where direct measurement could hardly be done, say in finding inaccessible heights and unknown distances. For example, we find the height of a tree without climbing it, the width of the river without crossing it, and the size of an island without setting foot on it, or the length of a tunnel without actually seeing it. Because of the facility of the calculation by indirect measurement, trigonometry has helped a lot in the development of other fields like surveying, engineering, navigation, and many others. Okay, so this is very true in our profession, especially in surveying, wherein you use triangulation to solve for areas and distances. Okay, so this is a very important topic. In the succeeding discussions, it is therefore advisable to adopt the following procedure in solving problems involving triangles. So first, draw a diagram to represent the problem situation. If a diagram is not given, or if a figure is not given, it's suggested that you imagine it on your own. Identify the triangle needed to be solved, needed in the solution, whether it be a right triangle or even an oblique triangle. Indicate the known and unknown values in the figure. Use the appropriate trigonometric function needed in the solution. Okay, so this is roughly a guide on how it will make it easy, or how it is to make easier the solutions or the applications of right triangles. Moreover, so it would help a lot to recall the following theorems about parallel lines. So parallel lines are everywhere equidistant. Parallel lines are lines that do not intersect. Okay, so two vertical lines are parallel lines because they will not intersect each other. If two parallel lines are cut by a transversal, then A, alternate interior angles are congruent, equal. Corresponding angles are congruent. Alternate exterior angles are congruent. Interior angles on the same side of the traversal are supplementary. Many problems involving right triangles use the concept of angle of elevation and angle of depression. So the following definitions are therefore necessary in order to solve practical problems involving these angles. Okay, the second statement right here, number 2, deals with your angles of elevations and angles of depression, because sometimes, okay, an angle of elevation can be translated into an angle of depression following the principle of parallel lines. So later on you'll see what we are talking about here. The angle of elevation, so here it is, an example, okay, is the angle made with the horizontal by the line of sight from an observer to an object on a higher level than the observer. So for example, if you are seeing an object, or if you are looking at an object that is now above you, okay, so the deviation or the subtended angle, okay, from your horizontal line of sight, because the usual line of sight is horizontal, correct, to that object above, okay, so that sweeping angle, or that angle that you form, that rotation that you form with your line of sight, is the angle of elevation. Okay, so take note, for the angle of elevation, it's always higher level. So the object is always at a higher level than your line of sight. Okay. For the angle of depression, so the angle of depression is the angle made with the horizontal by the line of sight from an observer to an object on a lower level than the observer. So this is quite the opposite. If you're for the angle of elevation, you're looking at an object above you. here, for the angle of depression, you're looking at the object below you. Okay, but as always, the standard or the baseline is always the horizontal line of your line of sight. Okay, so the angle of elevation is looking up, the angle of depression is looking down. Okay, so these two principles are very important when we now discuss your applications. Okay, so here is our first problem for the applications of right triangles. So from a point 49.5 meters from the base of a flagpole, the angle of elevation to the top is 43 degrees 12 minutes. Find the height of the flagpole. Okay, so as with any problems in or worded problems in any subjects, it's always best if you can draw the figure so that you can visualize what is being described. So here we have a flagpole. Of course, a flagpole is always vertical, right? It says here from a point, let's say 49.5 meters from the base of the flagpole. So I'll draw it from the left or to the left side. Okay, so this is 49.5 meters. The angle of elevation, meaning if you look up at the top of the flagpole, you'll create or you'll subtend an angle that is 43 degrees 12 minutes. Okay, so here from this particular point, 49.5 meters from the base, the angle that you're going to make is 43 degrees 12 minutes. Why is this relevant? Well, because imagine if you go closer, right? If you go closer towards the flagpole, less than 49.5, what do you think will happen to the angle of elevation? Will it increase or will it decrease? So the angle of elevation will actually decrease, right? Because you're now closer to the flagpole. So it's just asking from this particular point, okay? So from this particular point, maybe he measured, or the observer measured the distance from the, flagpole, and then measured also the angle of elevation so that he would know what will the height be. Because without trigonometry, how will you measure the height? Of course, you measure it manually along the flagpole itself, okay? So you get a very large or a very long stick or with gradation, right? And you measure it from the bottom to the top. But since that is not really efficient, correct? You don't expect measuring it vertically, you can use trigonometry. So you step away, let's say 49.5 meters from the flagpole, and then you look at the angle of elevation to the top. That gives you now a right triangle. Is this a right triangle? Yes, because a vertical line always makes a 90 degree with the horizontal. So we assume that this is the horizontal ground. Okay. So what is being required here? So let's name our triangles. So usually we name the triangles by their vertex, correct? Vertices. So let's say this is point A, the point of observation. The top of the flagpole is point B, and then where the flagpole is planted on the ground, that is now point C. Therefore, the corresponding sides will be defined. So the opposite side to A is side A, the opposite side to B is side B, that is 49.5. The opposite side to C is side C. Okay? So this is now your triangle. Okay? So this is not the same as the solution of right triangles. For solution of right triangles, you're given quantities or properties of the triangles and you solve for the rest. Okay? So if you're given a side and an angle, you solve for the other sides and the other angles. But here it's not. For the application, we're only concerned with what is being asked. And what is being asked? The height of the flagpole. In our triangle, the height of the flagpole is side A, correct? So side A. So how do we solve for side A? Okay, so we use our principles developed from the previous discussions for solutions of right triangles. You have your 6 trigonometric functions and you have your Pythagorean theorem. What is given here? We have angle A, correct? Angle A is 43 degrees 12 minutes. That is our angle of elevation. And then we have, what is this? 49.5 is actually side B. We're looking for the height, which is A. So what function are we going to use? Can we use the Pythagorean theorem? No, because the Pythagorean theorem requires all of the sides to be, or 2 sides to be given. Here we're only given one side and an angle. Okay, so we're given A, so sine, cosine, tangent, all of them has A. We are given side B, so sine does not contain side B, so we cannot use this. Cosine A, it contains side B, okay? And tangent A contains side B, which is here. But our unknown is A, so which contains angle A, side B, and side A. That is your tangent function. So tangent A, side A, and side B. So this is the formula we're going to use. So here it is. So we use the tangent function. So substituting the known values, we have this. So the tangent is opposite over adjacent, so TOA, right? Tangent 43 degrees, 12 minutes is equal to opposite, that is side A over adjacent 49.5 meters. Cross multiplying 49.5 to tangent 43 degrees, 12 minutes, we get this particular expression for A. So A is now equal to, if you compute this in your calculator, A will become 46.5 meters. Therefore, the flagpole is 46.5 meters high. So that is it. That is how you solve worded problems for trigonometry using right triangles. However, if you cannot draw or imagine the scenario properly, and if you cannot identify the triangle, you will not be able to solve the problem. Okay? Next, let's have example number 2. Okay. So from the top of Mount Banahaw, 135 meters high, it is observed that the angle of depression, which is depression, okay, of a ship is 21 degrees. How far is the ship from the top of the mountain, and how far is the ship from the foot of the mountain? Okay, so this time we have an angle of depression. So the observer is no longer below the object being observer spotted. The observer is now above. So probably there's an observer at the peak or at the top of Mount Banahaw looking down on a ship out in the sea. Okay, so the observer measured its angle of depression, or what rotation did he tilt his head to, or his instrument to spot the ship. And he saw that the observer observed an angle of 21 degrees. Okay, the Mount Banahaw is also 135 meters high. So this is our scenario. Next, I think we should identify our triangle. So where is our triangle? So if we form a line connecting, okay, the top of Mount Banahaw to the ship out in sea, okay, and if we connect it to the distance horizontally from the ship towards the foot of the mountain, and then go back to the height and traverse the height, we will form a right triangle. So this is our right triangle highlighted by the red line. Okay, how do we fill in now the values of our right triangle? Okay, so let's say, for example, this 135 meters is one leg of the triangle, correct? Let's say this length here from the top of the mountain to the ship, let's call it D, is now, okay, the hypotenuse of the right triangle, correct? And this distance from the ship to the base, okay, from the mountain here, is now X. So we now have a right triangle. What about the angle? So let's take a look at here. Here, to the problem, it says that the angle of depression from the top of the mountain, okay, towards the ship is 21 degrees. But also here, from the ship, if you observe, the angle of elevation, okay, of the top of the mountain from the ship is also 21 degrees, okay? So this is what we're talking about when we mentioned a while ago, parallel lines. Where are the parallel lines? Here. There's an observer at the top of the mountain, and if there's also an observer from at the ship, correct? If they are going to spot each other, they will create equal angles. The angle of depression from the top of the mountain will be equal to the angle of elevation from the ship. Okay, so I hope that is clear. So this is now our right triangle. So what is being asked? First, how far is the ship from the top of the mountain? So most probably, okay, this distance is the straight distance from the top of the mountain towards the ship. So this is now the hypotenuse of our particular triangle. Okay, so for D, how do we solve this one? Since we are solving for hypotenuse, we are given an angle, we are given a height of 135. What function should we use? Okay, so here is our angle, 21 degrees. 21 degrees, okay, is opposite of 135. We are looking for the hypotenuse, okay, angle, opposite, hypotenuse. So that sounds like our sine function, because sine is equal to opposite over hypotenuse. So, from SOHCAHTOA, correct? So, opposite over hypotenuse, therefore we use sine. So, sine, 21 degrees, is equal to its opposite, 135, the height of the mountain, over hypotenuse, D. Solving for D, we get this particular expression, 135 over sine 21 degrees. D, if you compute it, becomes 376.708 meters. Okay, so that is now the distance of, if you connect a line from the top of the mountain to the ship itself. Okay, now what about how far is the ship, or the distance of the ship, okay, from the foot of the mountain? So we let X, as I said a while ago, the distance of the ship from the foot of the mountain here. So this is now a horizontal distance, okay? So we have an angle, 21 degrees, again. We have its opposite side, okay? And we're looking for the adjacent side. So angle, opposite, adjacent and adjacent, that is tangent, correct? Tangent is equal to opposite over adjacent, or TOA. So we're going to use tangent. So tangent 21 degrees is equal to opposite 135 over adjacent x. Solving for x, x is equal to 135 over tangent 21 degrees. Therefore, x is 351.687 meters. Okay? So that is how you solve this particular problem. So it's still very easy for now, correct? We're just using two functions, or we're just using trigonometric functions. Again, the key is in the imagination of the scenario, of the problem itself. Then draw your triangle and then find the function applicable. Okay, example number 3. So this one is a bit different. So a man standing 9 meters above the ground observes the angles of elevation and depression of the top and the bottom of the Rizal Monument in Luneta as 6 degrees 50 minutes and 7 degrees 30 minutes respectively. Find the height of the monument. Okay, so let's say here's the monument of Rizal in Luneta Park. Okay, and there is a man standing, let's say 9 meters above the ground. So we don't know how he got there, correct? So he's standing 9 meters above the ground. It's now asking us what is the height of the monument if the angles of elevation of the top of the monument is 6 degrees 50 minutes, and if the angle of depression of the bottom part of the monument is 7 degrees 30 minutes. So how do we find the height? Okay, obviously the monument is greater than 9 meters, correct? It's greater. We know this because if the monument is less than 9 meters, then the observer should not be looking up, right? The fact that he is looking up still, even if he is 9 meters above the ground, meaning that the monument is 9 meters higher, or is 9 meters, or the monument is still higher than the observer. Okay, so how do we solve this particular problem? Let's see. So the height of the monument, okay, where this is it, correct, is 9 meters plus whatever this distance here. Let's call it x. Okay, so let's call this one x. These are completely arbitrary variables, correct? So you can choose whether this be, let's say, h sub 1. It's up to you. So usually y is denoted for the vertical, but let's just use x for now. Okay, so the height of the monument is equal now to 9 meters, correct, plus whatever this distance is, x. Okay, so let x be the vertical distance from the man's horizontal line of sight to the top of the monument. So whatever this is, correct, so whatever this height is, that's the vertical distance. Okay, so if we're solving for h, the height of the tower, we need x, correct? So how high from the horizontal line of sight of the man the tower is the tower. So we need that. So how do we solve that? Well, if we look at a particular triangle here, we're going to create one particular triangle, correct? So let's say the angle of elevation is 6 degrees 50 minutes. The height, this one, is x. And let's name this particular variable, or this distance, okay, the distance of the man from the monument, as y. So if we create this triangle here, we'll create an expression of what? Tangent 6 degrees 50 minutes is equal to x over y. Why is that? Tangent 6 degrees. Tangent is opposite over adjacent. The opposite of this angle is x over y. Correct? Opposite x, adjacent is y. Meaning to solve for x, okay, we need cross multiplying y here. X becomes y tangent 6 degrees 50 minutes. So we cannot solve x yet because x needs y. We cannot solve h yet because h needs x. Okay, so solving h is equal to x plus 9. Turns out x is equal to y tangent 6 degrees 50 minutes. So before we solve h, we solve x. Before we solve x, we solve y. Okay, how do we solve for y? Well, fortunately, we do have another triangle here, the triangle here below, formed by the depression or angle of depression of the observer. Okay, so for this particular triangle, what do we have? We have an angle 7 degrees 30 minutes. We have its opposite side, which is 9, okay, the height of the observer from the ground, and we have its adjacent side, which is y. Therefore, we have a function of tangent as well. That is now tangent 7 degrees 30 minutes is equal to opposite 9 over adjacent, which is y. Solving for y, well, now y can be solved, correct? So solving for y using algebra, that is now 9 over tangent 7 degrees 30 minutes. So inputting this in your calculator, it turns out that y is now the horizontal distance between the man and the monument, is 38.362. If you have the value of y, so remember that we need y to solve for x, we can now solve for x. So put this value of y here, x is equal to 68.362, tangent 6 degrees 50 minutes, that will give you x equal to 8.192 meters, okay? Now that we have a value of x, remember we need the value of x to solve for h, so x turns out is what? So even if the man or the observer is 9 meters from the ground, the height of the monument or the top of the monument is still 8.192 meters, okay, higher than the observer. But if you want to solve the total height of the monument from the ground, of course you add 9. So the height of the monument becomes 17.192 meters, okay? So this one is a bit challenging because we are now using or now combining two right triangles. Nevertheless, the function is just tangent, okay? So you just need to be able to visualize the question or the problem and then form your triangles and then choose the correct or the corresponding function, okay? So that is it for example number 3. So the last one for right triangles, okay? So example number 4, okay? So from a point A, the angle of elevation to the top of a tree, okay, is 46 degrees 10 minutes. While from a point D, 50 meters farther from A, on the same level, the angle of elevation to the top of the tree is 27 degrees 45 minutes. How high is the tree? Okay. So here we have two sets or 2 points of observation. So if you want to measure the height of the tree, okay, so probably, okay, A to C, there is something here. Probably there's a river here, correct? So that's why the observer at A initially could not have measured the distance AC. So what he did was from A, okay, he took an angle of elevation to the top of the tree, okay, and then moved 50 meters farther back and then measured again the angle of elevation. So notice that the angle of elevation decreased, correct, as the observer stepped away from A going to D. Okay, so this is our particular problem. Okay, so here it says that notice that we have two right triangles. Okay, so do we have two right triangles? That is now triangle DCB. Where is that? DCB, that's a right triangle, that's the large one, and ACB, correct? So ACB. The figure shows two unknowns, namely x, let's call this x, the distance from A to C, and h, the height of the tree. However, we are only interested in the height of the tree, correct? Inasmuch as no information is given about the length of the hypotenuse of either triangle, so we don't know DB, we don't know AB, correct? We use a trigonometric function that does not involve the hypotenuse because we don't have any data on the hypotenuse. Hence, we use the tangent function. Okay. There's actually a third triangle here. So if you see it, you'll notice that we have an oblique triangle, correct? That is your DAB. That is an oblique triangle. But since we are in a solution of right triangles, we're going to solve this using right triangles. Okay. So we want the height h. Okay. So solution. In triangle ACB, that's the smaller triangle here, ACB, tangent 46 degrees 10 minutes is equal to h over x. So how is that? So tangent 46 degrees 10 minutes is equal to opposite over adjacent, so height over x. So solving for h, that is equal to x tangent 46 degrees 10 minutes. So again, in order for us to solve h, okay, we need to have the value of x. In triangle DCB, so in triangle DCB, the larger right triangle, okay, tangent 27 degrees 45 minutes is equal to opposite, okay, over adjacent. Okay, so the opposite side here is obviously still h, the same, correct? But the adjacent side is no longer x nor 50. It's actually the combination of 50 and x, correct? Because this is your larger right triangle. So the distance here, the adjacent side for 27 degrees 45 minutes is 50 and x, 50 plus x. If you use only 50, then that is wrong, okay? That is not the adjacent side of the larger triangle DCB. Okay, so tangent 27 degrees 45 minutes is equal to h over x plus 50. So if you notice here, h is equal to quantity x plus 50 tangent 27 degrees 45 minutes. Now, since we're done with the module 4, linear equations, remember, if you have two unknowns, you need to have two equations. So we do have two equations here, so we can solve either by substitution or elimination. Okay, so equating the two expressions which are equal to h. So these two particular values, correct? H is equal to x tangent 4610 degrees and h is equal to quantity x plus 50 times tangent 27 degrees 45 minutes. These are the same, correct? These are the same values of h, so you can equate them with each other. So you're actually equating the right side. So if you equate these two, we have this particular equation, okay? So how many variables do we have now? We only have one, that is x, right? So solving for x, we get what? So I guess we can distribute first tangent 27, okay? It becomes this. Then we can transpose this to the left side. It becomes negative, okay? Then we can factor out, okay, x. If we factor out x, that is now tangent 46 degrees 10 minutes minus tangent 27 degrees 45 minutes. Dividing both sides by this particular expression, we get the value of x as 50 times tangent 27 degrees 45 minutes all over tangent 46 degrees 10 minutes minus tangent 27 degrees 45 minutes. So input this in your calculator. Be very careful on the degrees and minutes, okay? You'll get 51.035 meters, meaning the distance AC is actually 51.035 meters. Now, how do we get the value of h? Well, we do have two equations for h, correct? So the first one from triangle ACB and the second one from triangle DCB. So we have a value of x. So if you substitute the value of x in either one of these equations, you should get the correct value for h. So I'm just going to use the easier one, the x tangent 46 degrees 10 minutes. So substitute, okay, 51 here. You're going to get h equal to 53.2 meters. Therefore, that is now the height of the tree. If you want to check this, use the expression or use the second one from triangle DCB. H should be equal or the same. Okay, so that is it for your solutions of right triangles. The very important thing here is for you to draw the scenario or imagine the problem, draw your triangle, and then choose the correct function to use. Okay, so questions, kindly write them in our inbox in Canvas, and I'll try to answer them, or whichever your instructor is, okay? We'll try to answer them for you. And that is it for this particular module. I'll see you on the next one. Thank you.